In this video, we are going to take a look on how to use GLSL shader programming language in a Panda3D application or a game. So we are going to create something like a gradient shader in this video, so the end result will look something like this. And I created this shader a few years ago when I created the Cocos 2D series. So this is done by GLSL. So it is a gradient shader, so it starts with a blue and it fades out to this greenish color. So it can be used as a background for a 2D or a 2.5D game. So, and I'm just going to show you quickly one more scene, which is 05, and here I combined two shaders. One is a vignette shader, so as you can see here in the corners are a little bit darker, so this is called vignetting or vignette, and also the gradient, so the blue goes to the green, and this is the, let's say, the player area, so the ground. So we are going to recreate the first scene, which is this gradient in Panda3D. I already prepared the code which creates a Panda3D window, and the window size will be 1280 by 720. And here I'm setting the background color of the window to pure black, so 000, setting the camera's position to 0, -40, so it moves the camera back on the y-axis. And I'm also loading a plane, so self.loader.load model from the My Models folder, which is this one, and it's called plane.egg. So plane.egg. And I'm also reparenting this plane to the renderer, so it's get added to the scene graph, so it will be visible. And if I run it, I have just a simple plane, a white plane, nothing interesting, and also the window size is 1280 by 720, and it also shows the frame rate meter in the upper right corner of the window. So we are going to use GLSL shader to actually color this plane. So GLSL shader, especially the fragment shader, runs for every pixel for this geometry. The vertex shader runs for every vertices, so this plane has 4 vertices, so the vertex shader will run for those 4 vertices, but the fragment shader will run for every pixel inside this plane. And I'm just going to show you one more thing. I'm going to uncomment this line, which sets the wireframe, and as you can see, this is just a simple plane, so 1, 2, 3, 4 vertices, and also it is just divided into 2 triangles. So I'm just going to comment out this line again. And the 2 shader we are going to write, one, as I said, one will be a vertex shader and one will be a fragment shader. So let's get started with the vertex shader. So I prepared here a folder called shaders, and I'm just going to right click, new, and GLSL shader. You have to install this plugin if you want to have this option here. So you can search in PyCharm in the plugin section for GLSL shaders. So let's click on this one, and I'm just going to name it gradient dash vert, because this is a vertex shader, dash vert, and I'm just going to give it the file extension GLSL. Okay, so for some reason, I don't know why, but this plugin is somehow broken, because it should have syntax highlighting, but it worked earlier, but it doesn't work now. So the syntax highlighting and the syntax checking is broken. Okay, so I'm just going to use version 1.2, which is OpenGL version, I think 3 or something like that. I'm not sure now. So I'm just going to use GLSL version 1.2, and here we will need uniform, which will be the model view projection matrix, and I'm just going to copy it from my second monitor. So uniform of type matrix 4 and P3D underscore model view projection matrix, and this is a built-in. So if you go to Panda's documentation in the shader section, you will find that this is already set up for you. So, and this is the model view projection matrix. So I'm just going to show you something on the internet. So if you want to learn more about OpenGL and the shaders and how all these model and view and projection matrices are working, or you should go to learnopengl.com and read through this website, because this is the most, I think, the most, not the most, but the best learning resource for OpenGL and shaders and this kind of stuff. So, and if you go to getting started, just go to coordinate systems, and here it shows what does the model, what does the view, and what does the projection matrix. So the model matrix moves the model from local space to vert space. The view matrix moves the model from vert space to view space, and the projection matrix moves the model from the clip space. So that's why it is called model view projection matrix, because this is a combined matrix of these three matrices: the model, the view, and the projection. And as I said, this is already added in Panda, so you don't have to create it. The next thing will be actually to create or use the void main function. So I didn't told you, but GLSL is a separate programming language, and with GLSL you can program the GPU. So I won't teach you the basics of GLSL. If you want to learn more about GLSL programming, just search on YouTube and also on Google, and you will find some resources. So the next line in the main function, I'm just going to set the GL position variable, which is also a built-in variable into GLSL. So GL underscore position will be equal to the Panda3D or P3D model view projection matrix times the P3D vertex. So, and the P3D vertex is, as I showed you, is these four vertices which gets passed to the vertex shader. So, and that's all what I wanted to do in the vertex shader. So we are just passing we're just multiplying with the model view projection matrix the vertex positions. So now let's create the second shader, which will be the fragment shader. So right click, new GLSL shaders, gradient dash frag, and that GLSL, and enter. So still going to use version 120. Okay, and it also needs, of course, a main function. And in the fragment shader, I'm just going to create a new uniform, and this will be the resolution. And so uniform of type vector2, and we will call it resolution. So uniform in GLSL means that we can pass from our front-end code, so from Python, from Panda3D, we can pass some values into the shader. Uniform is used for this purpose. And the next thing will be actually here in the MyGame class to load these two shaders. So to load the two shaders, the vertex and the fragment shader, we need to import the following module. So from panda3d.core, import the shader, and with the capital S. And here, after setting the camera position, I'm just going to copy from my second monitor. So my shader will be equal to the shader.load shader.add sl_GLSL, and I'm just going to move it on this line, and we are going to set the vertex and the fragment shader. So, and I don't know why PyCharm gives here this warning or this error. It looks like PyCharm didn't recognize that this load function in the shader module can actually take 2 more arguments. So as I say, the first argument is a type of the shader. We are going to use, of course, GLSL. So we can use, I think, CG shaders, but CG shaders are outdated. So we are going to use GLSL. And the second argument will be the vertex, and I'm going to set it equal to the shaders. So in the shaders folder, we have the gradient dash vert, the GLSL. So shaders gradient dash vert, that GLSL, and the fragment will be equal to the shaders gradient and dash frag that GLSL. So here we are loading the 2 shaders, and I'm just going to move it on the next line so it is a bit better readable. So we loaded the 2 shaders. The next thing will be to actually set on the plane. So self.plane.set shader to my shader. So we loaded the shaders, and we are setting on the plane to use this shader called my shader. Now let's take a look, and everything is white. It says here undefined variable P3D vertex. Let me see why it is undefined. So okay, I just find the problem. So here I'm just going to copy a comment. So this will be the uniform inputs, and we also have some vertex inputs. So I'm just going to copy these. So vertex inputs, and we have to set the input of type vector4 P3D vertex, and Panda will automatically pass the vertex positions to these P3D underscore vertex. So now if I run it, okay, there is no error. And as you saw, we didn't set the output color, so I'm just going to set one color. So we are going to use the GR_frag color in the fragment shader, and I'm just going to set it to vector4 of, let's say, 1.0 for the red, 0.0 for the blue, 0.0 for the red green blue, I mean, and 1.0 for the alpha. So this is a vector4, and now let's see. So now we should have an absolutely red rectangle. So every pixel of this rectangle or this plane is colored to pure red. We can set here, let's say I'm going to set the red to 0, and let's set the red green to 1, and now the plane will be colored to green. So these are the 2 most needed, I mean the most used, or how to say that, shaders, the vertex and the fragment shader. And as I say, the vertex just manipulates with the vertices, and the fragment shader manipulates with the pixel colors. Okay, so we created here this uniform, but we didn't use this, and we are going to pass some values to this shader. And to actually pass values to the shader, to the uniform input, we can do this with the following line. So self.plane.set shader input resolution, and this has to be the same name as in the fragment shader, so it is also called resolution, and it is a vector2 type, and I'm passing to this resolution these 2 values, the Windows width and the Windows height, so 1280 and 720, and I'm passing it as a tuple. So let's run it. nothing changes because we have to still use this resolution. We are not using it, we are just passing to the fragment shader this vector 2. And here, before I set the GL frag color, which is also a built-in output, something like output vector for GLSL, at least for old versions of GLSL, because GL frag color was deprecated after GLSL version 1.2. So what I'm going to do is create a vector 2, and I'm just going to just call it, I don't know, like position or pose, and to the following. So GL frag chord or fragment coordinates are also just built-in variables in GLSL, and we can get the XY of the frag chords or fragment coordinates, the X and the Y axis. And I'm just going to divide it by the resolution X, Y. So it will divide element-wise. So it will divide the X, the frag chord X, by the resolution X, and also the frag chord Y by the resolution Y. And it will save it into this vector 2 position. And now we are just going to set the frag color to this one. So red will be 0.3, the red-green will be 0.5, the blue channel will be set to position.y, and the alpha channel will be set to 1. So let's take a look. And it doesn't work. Let me see. Okay, of course not position, but just pose. So we created here this pose variable, so pose.y. And now we have this gradient, so it starts with blue and it fades to green. And this is vertically fading. If you want to have horizontal fading, just set this position y to position.x. And now it goes from green to blue horizontally, but I like it vertically, so I'm just going to change it back to position.y. So if you want to learn more about these built-in variables like the P3D Vertex or the P3D model view projection matrix, and generally about using GLSL shaders or shaders in Panda3D, just go to panda3d.org, go to the manual, Programming with Panda, and here you will find the shaders section. And as you can see here, Panda uses CG shaders, which, as I said, it's outdated, so it was developed, I don't know, by Google, or I can't remember. And here are the list of GLSL shader inputs. So click on this, and you will find all the list of shader inputs which are already predefined for you. So like you use the P3D_Vertex, you have also the P3D normals, P3D colors, so the normal vectors and also the colors. And this is actually, as you can see here, is the type. So this is vector 4, this is vector 3, this is also vector 4. Here you have the texture coordinates, also binormals and tangents, and just read through this. Here is the model view matrix. You have also just the projection matrix, just the model matrix, just the view matrix. You have a view projection matrix, so this is combined the view and the projection. Here is the combined model and the view, and all the combined matrices we used is the model, view, and the projection matrix we used in the Vertex shader, so the model, view, projection matrix. And for at the end, one more information. So if you want to know more about the GLSL versions, so we specified here that we are going to use version 1.2. Also for the fragment shader, version 1.20. If you want to know more, just search for OpenGL and GLSL versions and open this Wikipedia page. And here you will find a table that version 110 is for OpenGL version 2.0. Version 120, which we used, is for OpenGL version 2.1. And the version 130 is for OpenGL version 3.0. So you can find a table, you can just check which GLSL version works with which OpenGL version. We can also just set this to 1.30, also in the Vertex shader 1.30, and it will run without any problem, but it will give us this warning. So warning, global variable GL frag color is deprecated after version 1.2. Or 1, I don't know why I keep saying 1.2, it is 120. So although it works, but it is deprecated, so it is removed, I think, in version 3.3. I'm not sure. So you can also use with Panda version, the most recent version, which is version 460, and also OpenGL version 4.6. So that's all what I wanted to show you in this one, and I'm still planning to do a few more videos about shader programming or GLSL shader programming in Panda3D. So we will see in the next one, and thanks for watching and have a nice day.